Greetings. Welcome to our 43rd episode of the FGI podcast series. My name is Tim Stark. I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign. On today's episode, we're going to focus on our September 22nd, 2022 webinar titled Revised Wind Uplift Design Methodology for Exposed Geomembrane Covers. I'd like to quickly reintroduce our presenter. Chung-Wing Lee obtained his PhD in geotechnical engineering from the University of Texas at Austin in 2005 with a focus on fiber reinforcement. He worked for Geocentric Consultants in Columbia, Maryland from 2005 to 2018, conducting geotechnical and geoenvironmental engineering design and construction on waste containment systems and soil reinforcement using geosynthetics. Chung-Wing is now a senior project manager working for Soil and Land Use Technology, Inc. in Glen Burnie, Maryland, and focusing on dredge material containment facilities, design, and conventional geotechnical engineering. So today, I want to focus on the questions from the live presentation that we didn't have time to answer, and the questions that we received after the webinar through the post-webinar survey. So, Dr. Lee, thank you so much for joining us again. And I will jump right into the questions from the live webinar presentation that we didn't get a chance to answer. So, number one, is there any data on suction beneath the geomembrane above a geosynthetic clay liner in a composite liner system?
I think it will depend on whether the GCL is hydrated or not. If the GCL is not hydrated, then air can still flow through it. For that case, I would treat the geomembrane over GCL the same as geomembrane over regular ground. If the GCL is fully hydrated, then I think it will be the geomembrane will be stick to it. Air will be very difficult to flow in. You will be able to maintain the suction below the geomembrane for a very long time. But unfortunately, I don't have any data on that.
Okay. Second question is, how do you protect the patch over the earth anchor system? There is a tendon to the anchor that is usually cut. Could that damage the patch that goes through the anchor where it goes through the geomembrane?
I have a sketch detail here. So when you apply pretension to the tendon, you are not pressing directly above the geomembrane. You will press against HDE load plate. The HDE load plate is about half an inch thick, and it has some bending stiffness. So this will distribute the load over a larger area and protect the geomembrane. And the final one, you will apply a HDPE geomembrane cap above the entire load plate to seal it.
Okay, great. Number three, are there fire-related issues with using the artificial turf cover?
Not that I'm aware of.
Okay. Number four, on the FGI website, there's actually there are two details for vents with flaps, one with a PVC pipe and one without. Yeah, great, it's on your screen right now, thank you. And these are to allow landfill gases to exit the cover if they were used in a cover. Actually, the details on the FGI website are for a water pond, and so these vents are actually in the bottom liner system to relieve gas pressure that could develop under the bottom liner system due to organics or something else. But the question is, have these vents with flaps ever been used to counteract uplift from wind? I wonder it could help prevent pressure difference from developing above or below the geomembrane.
For your reference, I have pulled up these vent details here, so you can build it as a two type of a vent design. I think it would be a good idea to have a flat cover that allows only airflow in one direction. This way you can maintain the suction below the geomembrane for a much longer period. And at the same time, it allows landfill gas to vent when there's any pressure buildup. If you have a regular vent that does not that allow air to flow in and out freely, then I would treat this vent as an opening, and you do the same as what we suggested in the webinar. You can just estimate the airflow rate through this opening, and based on that, you estimate how long the suction below the geomembrane will last.
Okay. Next question, how would an exposed geomembrane cover with vertical up/down slope anchor trenches react versus the top and bottom anchor trenches? In other words, you have an anchor trench at the top and the bottom versus up and down the slope.
We are talking about having an anchor trench oriented either parallel or perpendicular to the slope. For calculating the tension within the geomembrane, the approach will be the same whether it's the anchor trench is oriented in both directions. But for calculating doing the anchor trench design, whether the anchor trench will be whether the geomembrane will be pulling parallel or normal to the slope will have different effects on the pull-out capacity the anchor trench can provide, and it will need to be designed differently. There is a paper by Dr. Richardson published on GFR in the year of 2000. It talks very detailed about how to design it for the two different type of anchor trench oriented either horizontally or normal to the slope. You can refer to this paper if you want more information.
Okay, and Chung-Wing, is that reference in your slides, or should we provide it on the website?
It can be downloaded directly if you do a search on the internet. Okay,
and it's Greg Richardson?
Yes. GFR in the year 2000.
2000?
Yes.
Okay. All right, I may ask you for a better reference, and for the listeners, I will locate that reference and include it on the website with the podcast. Okay, next question is, why did you use artificial turf instead of real soil cover and grass in the example that you used in your presentation?
To clarify, I'm not advocating the use of artificial turf cover. It is just presented there as for information only. The artificial turf still has some advantage over conventional soil over geomembrane cover, because the cost will be significantly lower than that. At the same time, the artificial turf cover system still maintain most of the advantage of exposed geomembrane cover, so there's some benefit of using the artificial turf cover.
Okay. Okay, now I'd like to shift to the 4 questions that we received after the live presentation via the follow-up survey. Number 1, could we decrease the tensile deformation capability of the geomembrane by long-term exposure? Do you know of some information that describes the decrease in tensile properties of HDPE geomembranes per year of exposure?
To account for the long-term effect, we need to use a long-term design property of the exposed geomembrane. For example, the HDPE geomembrane will have a yield strength at 13%, but we cannot use 13% for the design. We use an allowable long-term design strength, which is typically 5 to 6% to do our design. If you want to know more information about how the geomembrane will degrade over time, I suggest that you look into the oven accelerated aging test of the geomembrane. So basically, the geomembrane will be put into the oven at a higher temperature. This will accelerate the aging. So you will be able to simulate the geomembrane after 10 years, maybe in 2 months of exposure. There's some published data on that, but I don't have any information regarding how much it will degrade over a year. I don't have that information right on top of my mind.
Okay. Next question is, what effect does rain have on wind uplift in a exposed geomembrane cover?
When it rains, it will effectively produce some pressure, which is helpful to hold the geomembrane down. But I don't think people should account for such effect because it's not we cannot reliably account for that.
Right. Agree. Next question. For a cover on a flat area, for example, a water catchment area, the slopes are usually less than 1%. What suction would be generated in this system when you don't have an embankment or basically a slope on which the geomembrane is applied?
A small feature such as a water catchment area that should not have significant effect over for a long slope. So I would just neglect this small feature and just use the average wind suction factor along the slope.
Okay. Last question. How do you account for surface roughness of the geomembrane? For example, a textured geomembrane versus a smooth geomembrane, and its impact on the suction factor that you used in your calculation? Yes, right here on your slide. Thank you.
Yeah, in the presentation, we had talked about wind tunnel experimental study test. We have test results for smooth HDPE geomembrane, studied the HDPE geomembrane and artificial turf cover, and there's a measured suction factor from this study. This paper, this information is available from the paper by Zhu et al. Published in in the year for 2022 in Geo Congress this year.
Right, and I'll try to
refer to this paper. So for any type of geomembrane that you are interested in, you can estimate the suction factor based on the similarity to this geomembrane type. Then you use the corresponding suction factor for your design.
Okay, great. And I'll try to obtain that paper and include it on the website. Okay, Chung Ling, thank you so much. Those are all the questions before or during and after the webinar. So thank you so much for joining us again from Glen Burnie, Maryland. And we look forward to maybe a future webinar.
Thank you very much. It's my pleasure.
Great. Thanks everybody for attending.
Bye-bye.